Hi, this is Christian Lyle for CS5453, and I'm going to be, oops, recording a video for the Hack the Box walkthrough, and I'm going to be doing it on the vaccine box. This is a tier 2 box, as I am a graduate student. I've already got the machine running, we've got an IP, I'll copy that, and oops, I've already got the starting point VPN running. Alright, so I've made this clean directory HTTP walkthrough, which we will be using. So to start off, as we do in these Hack the Box labs, we're going to do an nmap scan, just a standard scan, to see what services might be running. This will take a second, and once we get the services, we're going to uh, examine them and see what looks interesting and what we might be able to use to find our way into the machine. Just a second longer, maybe. All right. Well, now that that's done, what we're going to be able to observe, we can enumerate the ports, and we can see that there are three ports, 21, 22, and 80, running the services of FTP, SSH, and HTTP, respectively. And going back, I'm going to be using these task questions as a guide to give a comprehensive view of this box. So for test one, besides SSH and HTTP, what other service hosts on this box? That's FTP on port 21. And this service, as in referring to FTP, can be configured to allow login without any password for a specific username. What is that username? If we go back and we examine the FTP service, we can see down here anonymous FTP login allowed. So that login is going to be with anonymous. So if we go over and let's try to use the FTP service on this target. And we're going to specify the anonymous username because that's what we see in the results of the nmap scan, and this will not require any password for us. So FTP, it's going to be hosting some files. We can check what might be there using the dir command, and we can see one file, the backup.zip. And going back to Hack the Box, we can see what is the name of the file downloaded over the service. We can also see it's going to be backup.zip, and we can download this file using the git command. And that's going to transfer back to the directory from which we started this FTP connection. So if we go back to the HTTP walkthrough, we're going to get a backup.zip file there. And let's try using the unzip utility to get the files that are in the zip. Oh, and that's going to be asking us for a password. And we won't know this password at present, so but we can see there's an index.php file and a style.css file within this. So we're going to have to crack the password for this zip file. And if we go back to the task questions, this will give us a little guidance. What script comes with John the Ripper and generates a hash from a password protected zip archive to allow for cracking? So we're going to be using John the Ripper. It's a common password cracking utility with many options, many different modes. But what's going to be relevant to us here is the word list option. We're going to be performing a word list dictionary attack. And the way that we can do this is, as uh, kind of hinted at in the task question, we can use the zip to John utility to create a hash of the backup.zip file, and I'm going to send that to a file called zip hash. If we take a look at zip hash, we're going to see this is the hash of the backup.zip file. And now what we're going to do is we're going to use John. We're going to run it with, well, first before that, I'm going to be using the rocku.txt dictionary, which is a common dictionary used for password cracking attempts. So we're going to be running John in the word list mode using the rocku.txt, and we're going to pass it the zip hash. And it loads it. It says no password hash left to crack just because I've gone through this previously. If we do John show for zip hash, it's going to show us for backup.zip, this is going to be our password. So now if we run unzip again on backup.zip, we can specify that number password of 741-852-963, and we can see we've retrieved the index.php and style.css files. So now what we can do, we can examine these files, this PHP file. If we take a look at it, we're going to be looking at, let's see. So there's a header, Megacorp login. There's also title Megacorp login. So it's suggesting that this is a login page that would be hosted on an HTTP server. And if we take a further look at the PHP, we're going to see this line, if is set post username and is set post password. So if the username and password variables are set in post, we're going to check this next line. If post username is equal to admin and MD5 post password is equal to this, then we're going to have the login equal to true. So if the provided username and password are equal to these, then we're going to have a successful login. So that's great, right? We figured out the username and password for this web page that might be hosted on the target. But when we take a look at this password, it's kind of clear to us that this wouldn't be a password normally used by a human. And along with this MD5, it's going to be suggesting that this might actually be a password hash. And we can actually check this using a utility called hashID, where it will identify different hash types. So we're going to pass it the potential hash we found within the index.php, and that's going to give us some different hash types. But we're likely to be looking at an MD5 hash as suggested through the web page itself with this MD5 up here. So now what we can do to crack this is we can use hashcat, which is another password cracking utility. Once again, with many options like John. But what's important to us here is -m, the -m option, which specifies the hash type, and -a, which specifies the attack mode that's going to be performed. And if we scroll down a little, we can see the attack mode 0. That's gonna be a straight mode, which can be done with a dictionary. And if we scroll down a little further to these examples, we're going to see for an MD5 hash, the mode is going to be 0. So knowing that, what we're first going to do is we're going to, like with the zip file, we're going to send the password hash that we got. to a file. I'll call that pass hash. And now what we can do is we can run hashcat -a for the A attack mode, M for the MD5, and we're going to pass it the rocky.txt word list again. So it's going to do a straight attack on this, looking at pass hash as an MD5 hash with the rocky.txt dictionary. So that's going to run this, oops, that's going to complete very fast just because, once again, I've done this previously, but if we take a look, hashcat.m0, and if we show, we're going to see that this hash matches to a password of QWERTY789, and that's going to be for that index.php page with the username admin. So if we go back, if looking at the nmap scan, we know that there's an HTTP service running. So we're going to navigate to a browser. We're going to do HTTP, and we're going to look at this IP, the target IP, and we see the login page. So now we're going to attempt to log in with the admin and the cracked password QWERTY789, and we've reached a page, dashboard.php, as we can see. So now what we're going to be doing here is we're going to be continuing to look for an avenue for exploitation. So there's this search utility on this catalog page. Let's just make whatever query. And if we look at the URL, we see there's a variable called search with whatever. And that's promising for us because, as we know, anything constructed with user input for a service could be a potential avenue for exploitation, such as with, say, SQL injection. Now, we could, try to type an SQL injection command into this and construct it within the URL. Or what we can do is, to make this a little easier on ourselves, is we can use the SQL map service. Now, what this service is going to do, it's going to take a target URL and some other type of request, such as a cookie, and it's going to test different parameters and see whether they are vulnerable to something like an SQL injection attack. And like I said, one such request might be leveraged through a cookie, and such a cookie can be obtained through something like the Firefox cookie editor extension. If we take a look here, we've got a cookie with the name PHP SESSID and this value. So we're going to pass that along with the URL with the parameter that we're going to be testing to SQL map. And the cookie is specified, cookie equals. We're going to take the name, which was PHP SESSID. I'm just going to copy this. Oops. Well, PHP SESSID. And we're going to grab the value for it. So this is going to look at the URL with the cookie, and it's going to try and see if anything might be vulnerable on this page. And what that's going to find is the parameter search, it's got some different vulnerabilities. A stacked query vulnerability, time-based blind. But what this really means is that uh, it can be used as an avenue for exploitation. And going back, looking at the SQL map options, what we can do now that we know that search is a vulnerable parameter is we can prompt for an interactive shell. So we're going to use that OS shell option with the same command, same cookie, same URL. We're going to run that, and now we have an OS shell. And the commands we put here are going to execute or attempt to execute on the web page. So what we can do through this is what we're going to try to do is to attempt to create a reverse shell back to this Kali attacking machine. And we can do that by setting up an NCAT, a netcat, I should say, listener. We'll set that up on port 443. And now we're going to, through this OS shell, we're going to try to make this web server create a reverse shell back through the search parameter to our machine. So I'm going to start with bash.c. That's going to treat the following string as a command to be executed with bash. And then I'm going to do bash.-i. That's going to create a bash interactive shell. And that's for redirection. So, and we're going to redirect through a TCP connection of our IP adder. So we can find out what our IP is. This is our tunnel IP, 10.10.15.48. Oops. And that's going to be on port 443. And we're going to once again redirect some stuff. So this command, it's going to execute this string, which is going to create an interactive shell that is directed through a TCP connection to our machine on port 443. And let's take a look at our netcat listener, and we have a shell. We are logged in as user Postgres on the machine vaccine. So let's take a look at some of these directories. Let's navigate up, see what's happening here, and we see this file, user.txt. And if we take a look at that, that's going to be the user flag. So now that we're logged in as a user on the target machine, which we know is hosting an HTTP service, let's navigate to a common HTTP directory of our www/html, this common directory when a web page is hosted. And let's take a look. We see some of these files, which we've looked at previously, index.php, dashboard.php, this page, and we've already examined index.php, so let's take a closer look at dashboard.php and see what we can see. So once again, it's an HTML doc type. You can see title admin dashboard. And we're just going to be taking a look for anything that might be interesting. And here's something interesting. In this PHP session start, some more login stuff. It's going to try with user Postgres. That's the user we're logged in as. And we can see a password. p@s5w0rd exclamation point. So that is the password for the user we are currently logged in as. Now the shell that we're currently using, it's going to be pretty unstable. So what we can do now that we have a specified username along with password, we can exit this connection and going back, it's a little ways up. We remember that SSH is running on this machine. So with the specified username of Postgres that we were logged in as, we can connect back to the target IP. It's going to ask for the password. We know that it's p at s5 w0rd exclamation point. And we have successfully logged in. And we can see we are back where we were with the user.txt flag. And I'm going to go back to this because I neglected some of these questions. Task 5, we can see QWERTY789. The option that can be passed to SQL map, that's the OS shell option. And now that we are logged in with a stable connection to the target machine, we're going to be looking for a way to find the root flag. And to do that, we're going to need to do some sort of privilege escalation. And that might be commonly achieved through what can be executed through sudo. If we take a look at the task 7 question, what program can the Postgres user run as root using sudo? And we can actually check what would be allowed using the sudo-l command. Entering the password again. Oh, and what's important to us here, user Postgres may run the following commands on vaccine. We can see there's only one command that Postgres is allowed to execute using sudo, and that's a bin vi command. So vi, it's an editing command, and it's on the file pg_hba.conf, a configuration file. So we're going to have to find a way that through this command we can somehow escalate our privilege. So let's try running it. Bin vi etc postgresql 11 main pg hba.conf. And we're in this configuration file. What's actually in this file is not really relevant to us. What is relevant to us is the ability to execute some commands. We need to execute some commands with sudo privileges, which will be root privileges that will allow us to gain root access. And commands in vi can be executed using the colon, which will allow us to execute commands like writing, quitting the file, writing and quitting to save. But what's important to us is there is a command shell, which will spawn a new shell through vi. And we can actually set the type of shell that will spawn using the set command. So we're going to set the shell to the bin.sh shell. We press enter, it won't show the changes yet. But when we run shell, we spawned a new shell. Check who am I? I'm root. ID, we have the root ID. And this works because when running bin vi as sudo, we are running as root, and as such, the shell command and the set shell command that we perform are done as root. So we are spawning a new shell as root, and we are in, and as such, when we come to this new shell, we are root. And we can change the shell to a bash shell by typing bash. And we're still in the /var/lib class PostgreSQL directory with the user flag. Let's see if there is a home directory set. So if we press CD, it'll take us to the home directory of this root user. And listing the contents of that directory, we see root.txt. And if we list the contents of that, we will get the root flag. And that is the last step to complete the vaccine box. I hope that this was comprehensive and gave an idea of the different tools that were used in order to exploit it. Thank you.